Fourth far from the sun, Mars has captured humanity's imagination for centuries. But Mars is a cold, dusty desert. There's nothing there. In spite of this, Mars is the most studied world in the universe besides Earth. Now, don't get me wrong, Mars is cool. It might not be perfect, but it's a stepping stone for colonizing the rest of the galaxy. Until we find our own Pandora, it's the best place we've got. But this obsession with Mars makes all the other places in the solar system seem neglected in comparison. So today, we'll give these places the love and attention they deserve. First up is Mercury. The closest to the sun, Mercury is also a desert planet. Up until recently, it was considered pretty uninteresting, but the Mariner and Messenger missions have revealed that there's more to Mercury than meets the eye. Despite reaching temperatures of up to 430 degrees, there's strong evidence for water ice in its craters. Unlike Earth, Mercury is not tilted on an axis, so sunlight never reaches inside its polar craters. This allows for constant ice-cold temperatures. When Messenger looked into these craters, it saw what appeared to be light reflected from masses of water ice. The upcoming Bepi-Colombo mission will hopefully shed a light on how much ice is there and where it came from. Another mystery on Mercury is its chaotic terrain. Cracked, uneven, jumbled landscapes made of fractured rock, mismatched peaks, and collapsed craters. For 50 years, scientists have believed that this terrain was caused by earthquakes that rocked the planet after a massive asteroid impact. But a new study by Alexis Rodriguez and colleagues suggests that the terrain couldn't have been formed due to the impact because the two events happened 2 billion years apart. The study also found that areas within the chaotic terrain appear to have dropped, as if the crust below the surface just disappeared. The most simple explanation for this is subsurface volatiles. Volatiles are elements and compounds that can be easily vaporized, like nitrogen, carbon dioxide, water, and others. This is pretty cool because volatiles like water are necessary for life as we know it. If you want to learn more about this, I'll link the paper down in the description. One more thing about Mercury. It's the only rocky planet besides Earth to have a magnetic field. Scientists used to think that Mercury's core must have cooled down since its formation, but the core must be at least partially molten in order to explain its magnetism. Mercury's magnetic field also appears to be shifted up 400 meters to the north, not centered in the middle of the planet like on Earth. The orbiters for the Bepi-Colombo mission will hopefully shed some light on Mercury's magnetosphere. Next up is Venus. Known as Earth's sister planet, there's still a lot we don't know about it. Venus has over 1,600 major volcanoes and could have more than 100,000 or even 1 million smaller ones. In a recent study, researchers analyzed iron mons, a Venusian volcano 2.5 kilometers tall and 200 kilometers wide. They found that the volcano was active recently, anywhere from 10,000 to just a few years ago, but we have yet to see any of Venus's volcanoes in action. 4 billion years ago, Venus was much more Earth-like than it is today, and it likely stayed that way for around 900 million years. It only took 100 million years for Venus to transform into the hellscape we know today, caused by the brightening sun, volcanic outgassing of carbon dioxide from Venus's mantle and crust, and a catastrophic loss of liquid water. Even though life as we know it is impossible on Venus's surface, there's a level in its atmosphere that's the most Earth-like atmosphere in the solar system off of Earth. There you can find temperatures and pressures that will be comfortable for people. At this level, we've observed non-spherical particles the size of bacteria. Adding to the strangeness are gases in Venus's atmosphere. Most famous of these is phosphine. While many things could be causing the amount of phosphine seen in the Venusian atmosphere, life is a very compelling possible cause. We already know about these two. Next up is Ceres. Ceres is one of 8 dwarf planets and is the only one located in the inner solar system. It was the first member of the asteroid belt discovered when Giuseppe Piazzi discovered it in 1801. Ceres has multiple bright spots across its surface. For a while, onlookers joked about them being alien lights, but scientists now know they're actually salt deposits made mostly of sodium carbonate. And this salt comes from water that bubbled to Ceres' surface from a reservoir of brine deep in its interior. Scientists say that the reservoir is 40 kilometers deep and hundreds of miles wide. This reservoir makes Ceres one of the places in the solar system scientists would like to search for signs of life. Water is essential for life on Earth, so it's possible with a few other ingredients it could exist there. If life is found on Ceres, it would most likely be very small microbes similar to bacteria. Ceres' surface is covered in countless small, young craters, but none more than 280 kilometers in diameter. This is surprising because being in the asteroid belt, it's probably been hit with numerous large asteroids across its lifetime. The lack of craters might be due to layers of ice just below the surface. Ice or another low-density material like salt just below the surface could smooth out surface features over time. It's also possible that hydrothermal activity like volcanoes has erased large craters. Jupiter. Jupiter is the 5th planet from the Sun and the largest in the solar system. Its iconic stripes and swirls are actually cold, windy clouds of water and ammonia. Surrounded by dozens of moons, Jupiter also has several rings, but unlike Saturn, those rings are very faint and made of dust, not ice. The Great Red Spot is a massive, centuries-old storm over 16,000 kilometers across. But it's not known why the Great Red Spot is, well, red. Theories range from compounds of sulfur and phosphorus to organic material. Like Earth, Jupiter's core is made of a swirling molten material. This gives it a magnetic field 14 times stronger than Earth's, making it the most powerful magnetic field in the solar system. Humanity actually owes a lot to Jupiter. Its massive size attracts many asteroids and comets that, if not for Jupiter, would hit Earth. About 65 million years ago, an asteroid snuck by and triggered a mass extinction that would kill off the dinosaurs and make mammals the dominant life form on Earth. Without Jupiter, extinctions of this scale would be far more frequent and life might never have evolved on Earth at all. Next up, we'll look at the Galilean moons: Ganymede, Callisto, Io, and Europa. Ganymede has a diameter of 5,270 kilometers, making it the largest moon in the solar system. It's even bigger than Mercury and Pluto. Like Ceres, Ganymede has a subsurface saltwater ocean. This ocean is estimated to be 100 kilometers deep, 10 times deeper than Earth's oceans, and buried beneath 150 kilometers of mostly icy crust. Ganymede is the only moon known to have a magnetic field, which gives it auroras like the northern lights here on Earth. Telescope, astronomers have discovered that Ganymede has a thin, mostly oxygen atmosphere. Callisto is Jupiter's second largest moon and the most heavily cratered object in the solar system. Its rocky, icy surface is about 4 billion years old and has been pummeled by comets and asteroids. Callisto may also have an ocean 250 kilometers beneath its surface. This, along with its thin atmosphere made of carbon dioxide and oxygen, makes it a place where life could exist in our solar system. Io is the most volcanically active world in the solar system. It's home to hundreds of volcanoes, some erupting lava fountains dozens of kilometers high. This is caused by tremendous tidal forces from Jupiter, Europa, and Ganymede. At an orbit of 422,000 kilometers, Io crosses Jupiter's magnetic field, turning the moon into a giant electrical generator. This current then takes the path of least resistance back to Jupiter, creating lightning in the gas giant's upper atmosphere. Due to constant volcanism and intense radiation, Io is unlikely to host any life. Unlike Europa. In 1979, the Voyager spacecraft flew by Europa, giving scientists their first hints that the moon's icy surface was hiding a liquid water ocean. Ever since, there have been countless science fiction visions of life thriving in our European ocean. Scientists believe that Europa's ice shell is 15 to 25 kilometers thick and floating on top of an ocean 60 to 150 kilometers deep. So while it's only about a quarter of Earth's diameter, it may contain twice as much water as all of Earth's ocean combined. This vast, deep ocean is widely considered the most promising place to look for life beyond Earth. It may even be possible to study without drilling through 20 kilometers of ice. Data from the Galileo spacecraft suggests that thin plumes of water are being ejected 160 kilometers above Europa's surface. Next up is Saturn. With only 4 visitors compared to Mars's 50, Saturn is a rare destination. While not the only planet to have rings, none are as spectacular or complex as Saturn's. Saturn's rings are made of pieces of comets, asteroids, and moons that were torn apart before they reached the planet. The particles that make up the rings range in size from tiny, dust-sized grains to chunks the size of mountains. Saturn's North Pole has an interesting atmospheric feature, a 6-sided jet stream. It was first noticed in images from Voyager 1 and was observed more closely with Cassini. Spanning about 30,000 kilometers, this jet stream has wind speeds at 322 kilometers an hour. It is the only weather feature of its kind in the solar system. Saturn's atmosphere and incredibly fast rotation allow for some of the fastest winds in the solar system. In its upper atmosphere, winds can reach speeds of 1,800 kilometers an hour. While Saturn's extreme and volatile temperatures, pressures, and materials are probably too much for life to adapt to, life could be found nearby. Few places in the solar system are as interesting as Enceladus. Saturn's icy moon is one of a handful of worlds that have liquid oceans beneath their frozen shell, but Enceladus sprays this ocean into space where spacecraft can sample it. From these samples, scientists have found that Enceladus has most of the ingredients necessary for life: methane, salts, hydrogen, and organic molecules. This material also suggests that hydrothermal vents exist on Enceladus' seafloor. On Earth, these vents are home to rich ecosystems that live off the hot, mineral-rich water. The amount of methane on Enceladus is hard to explain. Serpentinization, the most likely chemical process, wouldn't create nearly as much methane as we observe. That much methane could be explained by methanogens, tiny microbial life forms that eat hydrogen and carbon dioxide and produce methane as a byproduct. On Earth, methanogens are found at deep-sea hydrothermal vents, like the ones thought to exist on Enceladus. Titan, another one of Saturn's moons, is an icy world with a surface obscured by a hazy golden atmosphere. The surface of Titan is one of the most Earth-like places in the solar system, although slightly colder. It's so cold, about negative 179 degrees, that water ice plays the role of rock. Titan may also have volcanic activity with liquid water instead of molten rock. Titan's surface is sculpted by flowing methane and ethane, which carves river channels and fills great lakes and seas with liquid natural gas. No other world in the solar system besides Earth has this kind of liquid activity on its surface. Vast regions of dunes stretch across Titan's surface, mainly around its equator. The sand in these dunes is composed of dark hydrocarbon grains thought to look something like coffee grounds. The dunes themselves are tall and linear, like those found in Namibia. Our solar system is home to over 150 moons, but Titan is the only one with a thick atmosphere. At the surface of Titan, the atmospheric pressure is 60% greater than on Earth, roughly the same pressure you would feel 50 feet underwater. Measurements from the Cassini spacecraft reveal that Titan has liquid water underground, likely mixed with salt and ammonia. This discovery adds Titan to the handful of worlds in the solar system that could potentially support life. Titan's seas, rivers, and lakes of liquid methane and ethane might be habitable, though any life there would be very different from life on Earth. Imagine two separate biospheres on Titan, life very different from ours on its surface, and life that might be more familiar in its subsurface ocean. Uranus is a cold, windy ice giant. Surrounded by 13 faint rings and 27 small moons, Uranus is actually tipped on its side and rotates at nearly a 90-degree angle. Uranus may be the most unloved planet in the solar system. The only close-up investigation of Uranus was in 1986 when Voyager 2 flew by the planet on its journey to Neptune. No other visits to the planet are planned. Discovered in 1781 by William Herschel, it was the first planet discovered with the aid of a telescope. Due to its unique tilt, Uranus has some of the most extreme seasons in the solar system. For almost a quarter of each year, the sun shines directly over each pole, plunging the other half of the planet into a 21-year dark winter. While most moons are named after Greek or Roman mythology, the 27 moons around Uranus are named for characters from works of William Shakespeare and Alexander Pope. One of two ice giants in the solar system, 80% or more of the planet's mass is made up of a hot, dense fluid of icy materials, water, methane, and ammonia above a small rocky core. Uranus's atmosphere is mostly hydrogen and helium, a small amount of methane, and traces of water and ammonia. The methane gas gives Uranus its iconic blue color. After Uranus is Neptune. Another lonely planet, Voyager 2 is the only spacecraft to visit Neptune up close. Dark, cold, and whipped by supersonic winds, Neptune is an ice giant. Galileo was likely the first person to see Neptune and marked it as a star in one of his drawings. But since he didn't identify it as a planet, he isn't given credit for its discovery. That credit goes to Urban Le Verrier and John Couch Adams, who both predicted a new planet would be discovered in a certain region of the sky. When Johann Galle discovered the planet in 1846, Le Verrier and Adams both took credit. Of all the gas giants, Neptune is the most dense. Scientists think there may be an ocean of super hot water underneath its cold clouds. It doesn't boil away because incredibly high pressure keeps it locked inside. Neptune's atmosphere has a similar composition to Uranus's, but for an unknown reason, it's a far more vivid blue. Despite its great distance from the sun, Neptune is the windiest planet in the solar system. Its winds can reach speeds of over 2,000 kilometers an hour, 5 times faster than the most powerful wind on Earth. Finally, we have Pluto, a complex and mysterious world with mountains, valleys, plains, craters, and maybe even glaciers. Pluto's tallest mountains are 2 to 3 kilometers in height and made up of water ice, sometimes coated in frozen gases like methane. Troughs and valleys as long as 600 kilometers add to the intrigue of this faraway planet. Craters as wide as 260 kilometers dot Pluto's landscape. Some of these craters show signs of erosion and filling, suggesting that tectonic forces are slowly resurfacing the planet. Pluto's most prominent plains appear to be made of frozen nitrogen and show no craters, but structures are visible, suggesting convection. Pluto has a thin atmosphere that expands when it gets closer to the sun and collapses when it gets further away, similar to the outgassing from a comet. Pluto has 5 known moons: Charon, Nix, Hydra, Kerberos, and Styx. This moon system may have been caused by a collision between Pluto and another similarly sized body. Charon, Pluto's biggest moon, is about half the size of Pluto itself. Because of this, Pluto and Charon are often referred to as a double planet. Pluto's other moons are much smaller, less than 160 kilometers wide. And there you have it. Other planets and moons in the solar system are way more interesting targets for future missions and probes than Mars. Visiting these places would require a bigger budget for NASA and more political will, but decision makers would usually rather go to the moon or Mars. Imagine a boat on Titan that could sail the methane seas, balloon probes on Venus to try and figure out if there's life hanging in the clouds, a submarine to explore the hydrothermal vents on Enceladus. Mars isn't the only neighbor in the solar system that's worth getting to know. Thank you so much for watching this video. I've been wanting to make a space video for a while now, but couldn't think of a topic, and this one seemed pretty good. Hopefully you've noticed that the film emulation is way better than my last videos, and that's because I've switched to DaVinci Resolve from Premiere Pro. Coming up, I want to make videos about the Moorish rule over Spain, a video about capitalism, and I also have a series coming up about the space race. So hopefully you guys enjoy your weekend. I'll see you in the next video. Bye!